In this video, let us see how we can export the files from the GeoWorkspace. After you have opened the project from the Project Output tab, you will reach this page. Then we have to go to this Exports and open it. Here we have 5 layers. They are the orthomosaic, DSM, DTM, point cloud, and the 3D model. First, let us see what the orthomosaic layer is. Orthomosaic is a map or collection of photos that are stitched together. When a drone surveys a land, it takes a lot of photos. Then the photogrammetry software stitches all these photos together and makes a single map. This is known as the orthomosaic map. And now let us see how we can export the orthomosaic layer. And there are 5 different formats here. First, we will look at the Geotiff format. Geotiff files are the raster image file types that are commonly used to store the satellite and aerial imagery data along with the geographic metadata that describes the location in space of the image. Using this button, we can export the Geotiff, and I have already downloaded the Geotiff file, so I am pausing the download. This is the folder where I have downloaded the orthomosaic file in Geotiff format. This is the file. Now we can drag it and open it in the CAD software. It is now asking for the insertion point. So we have to click anywhere on the file, and then it will ask for a scale factor, and then we have to give the rotation angle. And so once if we have specified all these things, it will start positioning the image. We have to wait while the software is processing. And now here we can click on this top view, and this is the orthomosaic map in Geotiff format. And next, let us download the world file. The world file has information containing the real world coordinates of the image, and it is used to georeference raster map images. Now let us open the folder containing the world file. In order to georeference the map, we have to keep the world file in the same folder as that of the orthomosaic file. We also have to make sure that these file names are the same. If not, we have to give the same file name. Here it is of the same file name, and now we can go to the CAD software. Here we need to type georef img in the command line here. Georef img is the tool that automatically reposition the raster images to the position defined in the images world file. If you do not have this tool, you need to install it. After typing the georef img, we have to hit the enter button. Now it asks to select the object, which is the corner of the orthomosaic image. After selecting, click enter. Now it has repositioned itself, and here we can click on the top here to view the orthomosaic image. Now let us check the other format, that is the JPG and world file. Download it using this export button. After downloading, open the folder. and it will be a zip file. Extract this zip file, and here we can see the JPG file and a .wld file. Drag the JPG file to open it in CAD. This is the orthomosaic file, and this file will be of small size. And this also contains the world file. We can also use the georiff img command to reposition it the same way that we did using the orthomosaic image. Next, let us download the GSD file. They are of two types. One is 5 cm per pixel and the other is 10 cm per pixel. GSD is also known as the ground sample distance, and it is the distance between the pixel centers measured on the ground. I have already downloaded the file. You can download using this export button. After finding the folder, here we will extract the GSD file with 5 cm per pixel. We can also import TFW files in AutoCAD, and we drag this TIFF file. Here I am using the QG software to view the file. Here we can see the orthomosaic file, and if we right click and go to the properties here, we can see the pixel size as 0.049. This is in meters. So when we convert it in centimeter, it becomes 4.9, that is approximately 5 centimeter. Similarly, we extract the GSD file with 10 centimeter per pixel, and we drag this and open it in the QGIS software. If we right click and go to the properties here, we can see the pixel size is 0.099. This is in meters, so when we convert it in centimeter, it becomes 9.9, that is approximately 10 centimeter. Next layer is the DSM layer. It is called the digital surface model layer. It has these following formats. Similarly, we have the DTM layer, which is called the digital terrain model, and it also has the same formats as that of DSM. I have now downloaded both the geotiffs of DSM and DTM, and now let us compare them. First, I am dragging and opening the DSM Geotiff file. And then the DTM TIFF file. Here, let us first look at the DTM layer. DTM is the digital terrain model that do not contain buildings or trees, etc. It only contains the terrain. While in DSM, here we can see that the trees and the buildings are there. And in DSM, it is used to get the elevation of the ground. While DTM is used to generate the contours on the land. And contours are the lines that show the same elevation on the ground. Next, let us go back and check the next format. The next format is the world file. It is the same as that of the orthomosaic only. This file contains information about the real world coordinates. And next we have the contour. This is used in the AutoCAD because AutoCAD cannot import DM geotiffs. For that, we use the contour feature available in the GeoWorkspace. In order to generate the contour, we have to select the contour. Then we can give the interval. Let us give here 1 meter interval. Then it asks us how much area to filter out. For example, if we give here 30 meter, and if there are any lower contours in the area and they are below 30 meters square, they would be automatically filtered out. And we can now export them using this button. Here we can see that now the contour is processing. Once it is processed, it changes to a blue color link. Then we can select the link and it will get downloaded. In the same way, we can generate the points. Here we need to select at what grid you want the point. And here I give 10 meter by 10 meter. Then we give export. The same way it would happen here. Here now it is in processing, and after processing, it changes to a blue color link. Then we can click on this link and it will get downloaded. Now let us open the contour file. Once we click on this link, our file gets downloaded. And after the file gets downloaded, if we click on the file, we will be redirected to the CAD software. And we can click on this top button to view the contours. These are the contours and they are labeled contours. They are also 3D contours. If we change the view angle, we can see that these contours are actually 3D contours. Every different elevation, the contours are available. And if we zoom into the file, we can see here that the elevation are marked for each contours. And if we go to the layer properties of this file, here we can see that there are 4 layers. One is the base layer, then the contour and the points and the label layer. The contour and labels are different layers. With this button, we can disable the contours. Here we can only see the labels, and if we select the mode and go to the properties, here we can change the properties like the color and the size. Here I am changing the color to red, and here I am increasing the height to 2. And here we can see that the color and size has been increased. Now let us import the orthomosaic Geotiff into the CAD software. So for that, here I am opening the folder containing the orthomosaic Geotiff. And I am dragging it to the CAD software. Here it is asking for the insertion point. So we have to click anywhere on the file, and then it asks for a scale factor and then the rotation angle. So once we specify all these, it will start positioning the image. And we next have to give the command georef image. And after typing, we have to enter the button. Now it asks to select the object. which is the corner of the orthomosaic image. After selecting, click enter, and now it has repositioned itself. Now we can click on the image and go to draw order and select bring to back. This will keep the orthomosaic image back and we can see the labels. In order to see the contour lines, we can go to the layer properties and then click on this button. And now here we can see the contour lines and the labels. And if we want to digitize the data like drawing the roads or marking location, you can create a new layer and start digitizing the data. We have also downloaded the point file. Now let us open the point file. It is a zip file, and once we extract them, we get two files. Now we have to open the .dxf file, and we will be now redirected to the CAD software. And clicking on the stop button, we can see the points. And at every point, we have the elevation label, and their point are georeferenced at a particular northing and easting. And the points in the AutoCAD are in the same northing and easting, whereas their elevation is labeled at the point. If we enter p-type, then we can select the point style and point size. Here I am reducing the point size and then setting the point size in absolute units. This way we can see the points better. We can also select any point and go to the properties, and here we can get the position and elevation details. And the same elevation label has been marked on top of the point. And if you go to the layer properties, the label and point layer are different. And we can change the label size and the color size the same way we did before. And we can also copy these point files to this file, and here we will get the points as well as the contour lines. And this is how we can view the point cloud in CAD software. Next, we can look at the slope. You can download using the export button. I have already downloaded, so I am locating the file and opening it in QGIS. Here I am dragging the file and opening it in QGIS. And here, if we right click and go to the properties, in symbology, we can give single band pseudo color and click on classify and then click on apply. Here we can see the slope. The red is the area having no slope and the blue is the area having high slope. Next, we have the DTM layer. Here we have the same formats as that of the DSM layer, and you can explore them like the way I did using the DSM layer formats. Our next layer is the point cloud. Point cloud is a cluster of multiple points. Points will be at 1 to 2 centimeter distance. Each 1 to centimeter distance, and when clubbed together, they are seen as the 3D model. There are two methods, the LAZ and the LAS. LAS file format is a standard format for storing the LiDAR data as points. It is a vector format, and the LAZ format is identical to the LAS and is compressed LAS. Now let us open the LAZ file. We are using QGIS to open the LAZ file. It will take some time to process. Here I am fast forwarding the video. This is the LAZ file. And here we can see that this is a compressed file and it is often used to transfer larger amounts of LiDAR data. And it is also smaller than LAS file. Now next let us open the LAS file. Here I am dragging it to the QGIS software. And this is the LAS file. And it is similar to the LAZ file. The final layer is the 3D model. It has only one format, that is OBJ. In order to download, we have to export the file. And I have already downloaded the 3D model file. And I am locating the file. And here we can see there are a lot of files. And we can use apps like 3D Builder to open the 3D model. Here we have to select this file and click on open. This will take some time to load the model. And after the 3D Builder app loads the model, we get a model similar to this present in the GeoWorkspace. Here let us wait for the model to load. This is the 3D model. After the 3D Builder app loads the data, we get a model similar to this. Here we can view the model at different angles. With this, we have come to the end of the exports and this video, and I hope that you have learned about how to export the files from the GeoWorkspace, and thank you for watching the video.